uh, kind of for you right now to ask questions and to understand. I'm representing here life insurance industry. So essentially life insurance, it's about how you issue life insurance policies, whom to issue life insurance policies, what premium to ask from them. If somebody is healthy, you really want to ask for low premium, this is true, yes. But how much low? How to quantify those things? When you start quantifying those ideas, data science comes into the picture. The data science is a broad umbrella. Within that umbrella, there are different terms coming up: predictive analytics, data visualization, optimization, storage. All those things are coming into this particular umbrella. And if you go ahead and look at the core structure of data science, this is what has been balanced there. So if you have some doubt what kind of tools and techniques to use in there. Before insurance, I have worked for banks creating their scorecard models. Scorecard models are like, there are two things when you go and ask for a loan. There is ability to pay and willingness to pay. How to quantify these two features. So this is again a complicated mathematics in there. Before that, I have done a little bit of web development, some tools development. I have tried to understand how to get these ideas from scratch or white paper to something which is implementable and can be showcased to auditorily. So I just want to sum up the panel that we have here from the industry point of view. So we have talked a lot about techniques and things from academia point of view and the techniques they are using. So going forward in the session, I want you to change your mindset and try to fit your understanding, whatever you have gained through last 1.5 days, into the industry representatives here. So when Vignesh and Shruti represent here technology industry. So just try to, in your back of your mind, try to create a picture. Data is everywhere. Different kinds of data is there. How these specific people in specific industry are using it. So Vignesh and Shruti represent technology industry, which is a high velocity data industry. There's a lot of data created every moment. If I will just keep free this particular room, people start on WhatsApp, Facebook, chat and all that. Everything is creating data. And these people are leading that wave of how to deal with that high velocity data. That is also data science. Now Devangana is doing a lot of interesting things. I mean, I will not talk about his thought works particularly. I will more talk about his data kind of work. Government is creating a lot of data. Just think about Jan Dhan Yojana. Jan Dhan Yojana is coming up with a lot of data with it. How many people are opening account, who is opening account, who is not opening account, where it is more successful, where it is not more successful, how to represent this information in a concise manner. This is just the open data. Government has provided you in something called data.gov.in. You can go there and find this data. Can you make value out of this data? Can you help the society, the people with that particular data? So Devangana and her team in Data Kind is doing something called open data analytics or government services. So it's one another area where you can start thinking and you can ask questions later on. Robbie represents healthcare. Now healthcare is a very broad field, and within healthcare I think you are just focusing on pharmaceutical, all this medicine stuff. Can you think about what kind of data is created in that particular industry? So Robbie will help us understand what kind of data this industry is creating. Just think beyond just columnar forms. This is field 1, field 2, field 3. Just think beyond that. What industry flavor will bring to the data? What kind of insights you want to look at? Then we have Dwapan. So Dwapan is working in a very niche area, and which is mostly linked to banking, but it's more important from a regulation perspective. How much loan a bank can give? Whom should bank give a loan? Do you really want to give a loan of 10 lakh rupees to somebody who just earns 5 lakh rupees? No. To what level you can give loan? To whom to give credit cards? What kind of risk that comes with? What kind of risk is you have when you give credit card to someone who can't pay? How to quantify those things? All the concepts start from your classrooms, but the only thing is you have to just start fitting them into industry pieces. Now we have Satya here. Satya industry is very interesting to share because most of the people, even in our circle, don't try to bring data science into the industry he's coming from. So he's coming from very niche semiconductor industry. Can you guys think of what kind of data semiconductor industry is creating? And can you make value out of that data? It's not just about making chips. How you can improve the quality assessment over the plant. So he is representing an industry which is very niche and people are not aware. People think data science to do with Google or Microsoft. But I am just giving you examples. Just try to fit your thinking in there. Then Karthik is representing retail and e-commerce. So all the data that you create on Snapdeal, Flipkart, all the data that all these Unilevers, Reckitt and Benexa, when they are selling the products, which advertisements to come up with, what to do, what not to do. All those things are very relevant for retail and e-commerce. But the ground thing, the basic methodologies and things are created from the courses and the kind of technical things we do. So we'll just carry on this discussion ahead, and I will try to focus more kind of industry perspective you can give and help the people to fit their academic kind of mindset into the way you will be getting ahead with it. So I will start with Robbie, and we'll just want to understand how your industry create data or collect data, and how this particular data is used into machine learning technology. And we just want maybe some examples to tell what kind of data is used.
So if you look at healthcare, it's one of the vital ones. Can you hear me actually? Hear me okay? All right. So it's one of the vital elements because it's there everywhere. We just don't realize healthcare. One way to assess the footprint of an industry is just look at the size of its footprint in the whole economy. Okay. So in the U.S., my reference is the U.S. industry, but I'm pretty sure it translates to the rest of the world. The whole economy is about $6 trillion, and the footprint of healthcare is about a third of that. About $2 trillion of the entire economy is somehow connected to healthcare. So that should give an idea. I mean, if you look, that's 33% of the entire economy is directly connected to healthcare. So that means that much of industry has to run on data. And in fact, it's a very unfortunate thing that it is one of the most primitive industries when it comes to data. Like, especially when it comes to data science. The data science has taken a huge leap when it comes to banking or insurance or e-commerce, like these guys, what they're doing. But when it comes to healthcare, it's very primitive. Like if you go to, Google and search for a movie ticket in Fun Mall, next time you go, you get a recommendation for Brookfield Mall, right? But if you go to a doctor, you take a child to a doctor, the doctor is actually clueless as to what other things are going around in his or her own vicinity. The doctor is totally clueless about what the child is going through. So it is actually a shame, but one of the biggest challenges is it's not one of the sexy areas and not many minds are there. But when you talk in terms of potential, that's where we come in. Like there are many, many data sources that are possible. So just to give, today, the biggest driver of healthcare, like the primary data source which the entire healthcare industry uses is actually what is called billing data. It's just, you go to a doctor, the doctor prescribes something and writes a prescription, maybe some medicine, and they might have done some procedures on you. That's get billed, right? So that information, okay, this person went to doctor on this day and this procedure was performed. That data is available. Then you go to pharmacy and buy some medicine. That information, this person bought this information on day A, this medication on day B, something like that. So that kind of data is the most reliable data available. And this is actually kind of shame, right? So where I see this heading is rapidly changing, like pretty much everything that touches, like if I just think about mobile, now this is enabling a lot of sources of data collection, like patients entering their own information and connecting. Then sensors, like you use Fitbits or things like that, which keep track of your heart rate, temperature, and all those things. These are getting collected in real time, and these feed into the IoT kind of data streams. Then other information, like when you do a blood work, or when you take an EEG, all those informations today pretty much stand in isolation, right? You take an ECG, the doctor looks at the data and puts it in a file and gives the data to you. But that data can be actually taken and mined. So think of a modern hospital where you go in, you see a lot of machines, right? Something blinking somewhere, some other. I mean, something as simple as even your weighing scale. You go on, what is one of the first things your doctor asks you to do? Take your weight, right? But even that data is isolated. We don't get information about that from all the population. So I'm not sure if it's over here, but things like a connected weighing scale. So every morning in the bathroom, you stand on it, your weight data gets uploaded to the central system, and suddenly collectively, even something as simple as a weight can act as a huge trigger. Like if there's a massive weight change in like 2 or 3 kgs in a week, the doctor can get elected. So the data sources are pretty much coming from everywhere. In fact, if I think about it, the thought process in the industry is, if there is a machine that's functioning, try to collect data from it. It can be anything, a weighing scale, a thermometer, a bed, how many times a bed is raised or lowered. If it is there, try to collect data from it. Like I was in a conference, it was just for health IT, and there were about 40,000 people over there, and more than 1,500, 2,000 vendors, and they're all working on one or small aspect of this thing. How can I collect more data about it? Now the challenge where people from Google and that kind of brains are coming and helping is, obviously if data is coming in from so many small streams, it essentially ends up with such a massive scale problem, right? Whereas these guys are already handling, from a technology perspective, they have already mastered it. So we are just bringing in new sources of data and leveraging such knowledge.
And I think Robbie just raised another very important thing, which is Internet of Things. So we will try to come back and see others' perspective also, because every instrument that you have which is running on a battery is creating some data. And there are challenges and opportunities attached to it. So I will go to Shruti now, because Shruti is doing a lot of interesting work on targeted ads. The major revenue source of Google is what? So did anyone search to Google and Google asked money to give you the answer? No, but still it's running, right? So somewhere they are making some money. So their main revenue source is, I think, still Shruti, if I'm not wrong, it's still data. Now Shruti is working into a very interesting area where they are identifying whom to show which ad and which ad will convert a person into a buyer for that particular product. So I will go to Shruti, and Shruti, can you just try to explain what this targeted ad management is and what kind of data you actually use to create this targeted ads within Google?
So basically, what my team deals with is trying to find users who have similar browsing history, like the users who are actually interested in the product. Say, for example, Vignesh is interested in Nike shoes, and he goes and browses the website, and the website actually collects data and says that people like Vignesh are actually interested in buying my Nike shoes. So what I work on really is that advertiser provides me with a basic set of users, say a bunch of 1,000 users who might be interested in one of these products. And what we do is that try to look up the browsing history of others outside to reach people beyond Vignesh or the 1,000 people in the list, and hopefully it reach the right audience so that they will probably buy Nike shoes, if that makes sense. So our data really comes from what advertising provides us, but the challenge really, what I think is that although people think that Google has a lot of data, there's no problem in actually getting data after working for Google. That's not completely true, because when you're modeling more specifically, the data really narrows down, and if there's just so much data, looking for the right data is the biggest challenge according to me. In my work, I think most of you have taken machine learning or data mining, would find this as from the textbook kind of a verse. But there's just three things which I built the entire modeling structure. One, the collection of data, and you might have so much data. So the next really important step would be the data processing, really finding what data in there is useful, and then finally converting all these into models. As part of my work, I think I've been dealing with all three stages, and I wouldn't really rate any of the stages as easier or the difficult one, because all three of them are equally difficult. And
let me just have a normal question on that. So essentially, she's trying to say your ad depends on what you have been teaching algorithm at the behind, what you are searching for more. If you are searching more for cricket, you will get ads related to cricket. If you are searching more for football, you will get football. So Shruti, I mean, if I just want you to ask to summarize, what will make person sitting here having ad A and person sitting just besides and having ad will be the key differentiators between who is getting what delivered onto their mobile devices or search engines or their blogs or maybe other sources?
I'm sorry, I'm not able to hear you clearly. Can you
Yeah,
repeat the
yeah.
question?
So my question is, what will differentiate between maybe Robbie getting an ad while browsing the same your Google search and Open searching the same Google search for last 1 month? What is the key things that you are actually looking at from algorithm point of view?
I'm just going to phrase the question, tell me if it's right or wrong. Are you asking me what features we look for in the search to actually target the right ads? Is that your question?
Yes, yeah.
Okay. So there are a lot of things. For example, if you probably search for something today, you might already have gotten a Nike shoe and you don't want to really target Nike again for you. It would be bad user experience, right? So there's kind of a browsing window we take. So there are a lot of features within the browsing window which we actually look for and target the ads based on the data we collect from there. Besides that, we also look for many other signals like the page signals. For example, if you're reading a page, you might be interested in the content inside the page.
Yeah.
There are multiple features that we look for, and it's just not the browsing history alone. But of course, browsing history is a very significant portion of it. And the challenge there is to figure out what is the right window and what would be the best features there to actually target the right ad to use.
Yeah.
Does that answer the question?
Yeah, it does. So essentially, I mean, just try to think of, if you search for a flight from Coimbatore to Hyderabad, then whichever page you visit, you will be getting ads from airline companies. Why it's happening? Because somebody clever like Shruti is sitting behind and making sure that if you search for a flight ticket, she will make sure that she will show you flight tickets so many times that you eventually book one and make value for the business. So thanks for this shrewd thing, Shruti. So maybe Vignesh, I mean, so there is a lot of data created from different sources. So I mean, if you just think of the kind of work Shruti is doing behind, daily you are browsing hundreds of web pages. A single person might be browsing hundreds of web pages. And there are so many people connected to Google from their different services, from their mobile phones, from their browsers, from different sources. So they are creating a huge volume of data, both audio, video, textual. So I think you work closely with a lot of this kind of data. So this is, I think, what we call high velocity data. So how you actually go about managing that, and can you give a ballpark image what volume of data you deal with in your normal working days?
Honestly, I can only say it's a lot. I actually have, so I work with, most of the time I work with videos. That means I pretty much work across all of the YouTube corpus, which I can't even estimate, it's just a lot. But in general, the main difference between what everybody else on the panel does and what I do is, I don't look at numbers, or I don't look at data the way the others do. I look at data more in terms of signals and digital signals and processing and things like that, because I work mostly with videos. But the key thing here with videos is that the scale is just unimaginably large. If you think processing terabytes or petabytes of numerical data is hard, then you should try processing like hours and hours of video streams. Like, for example, a simple thing would be copyright detection, right? So if you upload a video, let's say you just go to, I don't know, Kabali opening day and record the video and just post it on YouTube. And obviously you're not allowed to do that, and there should be some way of detecting that without just somebody sitting and looking, oh, is anybody posting videos of this on me? So no, so dealing with things like that at scale itself is, I mean, frankly, when I was in college, I was really amazed by how all these work. I really thought I could in no meaningful way have an impact on things like this, but turns out it's, when you understand most of the fundamentals, it's not that hard to do. I mean, I'm not downplaying what Google has done in building such an infrastructure, but it's most of it revolves around different kind of data, and you're totally in a different playing field where you use completely different set of tools, completely different set of algorithms. I mean, there is machine learning obviously, but not in the level that we normally do at Google, like deep learning, TensorFlow, and all that stuff. So that's pretty much
So guys, you know, I picked up a very interesting point from
different people with different kind of knowledge to this.
yeah, thank you, Vivek. So, you know, I picked up a very good thing from this. You know, Vivek, you know, next time don't go to a cinema hall, record videos and upload to YouTube, because Vignesh will catch you. He will catch you, and he will catch you using mathematics, statistics, on all the techniques which are available at our disposal. So, you know, there are a lot of people, whenever you go to some YouTube video, they will say that video is down because of some copyright issues. When there is volume is so high, so many videos are uploaded across the world, do you think that somebody is sitting there and clicking and seeing which is copyrighted or not? So these are these clever algorithms, something behind, and Vignesh is the policeman for that. You know, he is helping Google to deliver next generation algorithms to identify which is copyrighted material, which is not copyrighted material, and how to identify that. Thank you, Vignesh. So now I will just move on to the same similar kind of theme. You know, now Devangana is working with lot of government data. You know, government in multiple forms creates a lot of data and different kinds of data. Now, there is a difference between how Google operates in terms of storing data and using the data, and how maybe an NGO or maybe a small firm who just want to understand maybe credit related to farmers, credit related to maybe few NGOs letting it out, self-help groups if you are aware about them. So I will just ask Devangana, you know, so the data we just heard, you know, what kind of data is being generated through, maybe Shruti is talking about, they are generated through web browsers in your browsing history. Vignesh is having, you know, uploads, and Robbie just discussed about, you know, if you go to a pharmacy, you buy something, that is also data. What kind of data is dealt within this social kind of space and government services space? And actually, if you can touch upon maybe some specific example to connect with people, because this is something which is very less talked about in data science area.
Was that me or?
It's in Devangana. Hey Vignesh, this is for Devangana.
Okay.
So if you look at the open space, the open data, the challenges are very different because the sort of data is very different. Now you might look at something that is not very high velocity, but nevertheless has a very huge variety. So when you start learning about data, you'll find about different characteristics that define big data in the world. You probably nowhere come close to big data in the social space, but the challenges are probably much bigger than what you would believe in your technology space. So I'll give you a couple of examples just to understand what flavors of data comes in when you're talking about the open data world and the open space. So a lot of data in this space is actually captured via surveys. So there are population surveys in India, and all of that data is captured and uploaded on the government websites. There's a lot of data around the budget, the way budgets are allocated and they're being used. So for every single use of a portion of that budget, there's a report uploaded there on the web. There are public hospitals which use the open MRS, which is the open medical record systems, and all of this data keeps getting collected at centralized locations from all the public hospitals, and it is lying out there. People have started to sort of look into it, but not a lot of progress has been made there. Then there are a lot of open source tools. So there is an open source tool which a team in ThoughtWorks work for. It's called Rapid FDR. So there are these places in Africa, for instance, wherein they are the war zones. There are wars happening. The children are sort of separated from their families. They cannot find their parents, and somehow technology has to be used to solve problems like that, because those are real world problems. They are humanitarian problems. So there is an open source project which is called Rapid FDR, where you have a mobile application. You take a picture of the child and you ask the child whatever information he or she has about their family. So if they can remember their parents' name, or if they can describe their parents, or if they remember which village they came from, and so on. And you capture it in a simple mobile phone. But remember, you're working in very remote areas of Africa, and and you do not have access to internet there. So you have to solve these challenges of no connectivity, but at the same time storing this data temporarily, at least till the time you have internet connectivity, right? And you're dealing with text data here, you're dealing with images here, and so on. So that is one form of data that you would be working with. Another one that we at DataKind in Bangalore are working with, so there's this non-profit called Rande. It's basically a one microfinance non-profit. So there are people in the world who cannot afford to have a bank account. They need to have, they need loans for small things. So for instance, for financing education for their kids, they need small loans to start a vegetable shop. Now no bank would give them loan. And it's a very funny thing in India that people who are given loans by banks are probably the ones who really don't need them. So what Rande is trying to do is bring all of us together who can give micro credits in the form of say 100 rupee loan or 200 rupee loan to such people. So they are bringing people like us who can give micro loans to people who need these small loans to start their world. For them, their life is stuck because of the lack of money.
And I think I can just connect her point to broader idea of banking also. So she's talking about a very specific area where you need sophisticated ways to help out the end user of credit. Now you have to understand whom to give 100 or whom to give 200. Because it's true that in our nation, there are lives stuck for just 2,000 rupees. There are people in deep debts just about 2,000 rupees. 2,000 rupees is nothing if you go around with DataKind of solutions, crowdsource fund, or give it to right people. And I think there are a lot of things happening with what we call this microfinance institutions, and I think now RBI has also come forward and given licenses to them to operate as a bank also. And I think one of the best examples is Bandhan now. I don't think Bandhan has come to Tamil Nadu yet, but Bandhan has started an operation in AP, Andhra Pradesh and Telangana for sure. So I will just jump on to a very different topic here with Satya. So Satya usually works with, Satya is actually working in an area where he is trying to bring the talent on board and trying to groom them. Because these things are evolving very fast, and he is helping KLA Tenco, which is very niche field into manufacturing of your chip devices. You know, your Apple iPhone or your Microsoft Android phones, they have chips. Their chips making facilities also create a lot of data. How to deal with this data, how to bring the talent on, how to groom them, how to bring a solution out of it. So Satya, you can maybe talk about some examples on how it is evolving in your industry.
Yeah. So I think, so one thing we all know, and people who have seen our presentation is, we talk about how the mobile phone is shrinking, right? And the capability that's there in the mobile phone today, and the multi-dimensional facilities it has, right? So, and most of we provide technology powering it. So what, today the chips are manufactured at design node that's called 10 or 12 nanometer. That's where it's getting manufactured, right? So our job is to find problems in that dimension, right? So to do that, we generate gigabytes of data. Our tool generates gigabytes of data per second, and we consume it, and we do image processing and find problems from it, right? So that's what we typically do. And we have proprietary algorithms that work on image processing. And one of the challenges that we are trying to, we are heading down is our tools are independent, and we sell them into a customer fab, and it's there in the lab, and we don't have access to it. So once we put it out there, we don't have access to it. And our tools are so, kind of, they are slotted and they don't talk to each other. So we are trying to build our own cloud and try to, correlate information from one tool to the other, and try to do things there. So we are essentially, now we are telling our software engineers, if you want to stay relevant, start learning data, get into data analytics, right? Just don't do software development, start learning and then do it. And we have tied up with renowned folks from the Silicon Valley to start doing pilot training programs to train our software engineers in data science, and then start slowly spreading that knowledge. Right? So kind of any industry, has a pool of talent, it needs to start doing those things, and that's what we are doing. And we also are trying to, we do classification to find the defects. That's what we generally, our core of our business is we classify and find out defects. So most of them are models that are very tightly groomed, and so we're kind of going to random forest and now moving on to deep learning solutions. So that's another area where there is research happening, and we are trying to productize one of our deep learning solution on classification. So those are areas where data science.
So I think there is another point to emphasize, this is the right thing to emphasize is, data science is not about learning all these tools and algorithms. And it's also not just about learning what these different databases is. So data science is one of the technique which is truly multidisciplinary. You have to come from different backgrounds, have to observe different things and bring it together as a solution, complete solution. So I will not encourage you to go ahead and pick just one subject and focus it end to end. Just try to see how different things are happening and how they are converging into a solution for broader good. So a very good example is sitting here only. So Dawson from background is an economist. He has done bachelor's, master's and worked into economist kind of system. So you can think of how an economist is also finding a lot of value into data science, or kind of the tools and capability data science brings in. So maybe Dawson, you can tell students how coming from economics or other particular areas is actually helping you going forward into data science kind of broad umbrella framework.
So a little background about economics. I think most of the people over here, I think I'm the only person maybe I can bet that I'm the only non-engineer, non-computer science kind of a person sitting in this room. So economics is kind of not regarded as a absolute science. It's kind of regarded as an assimilation of science and liberal arts. And even like the Nobel Prize for Economics was not given until very recently as part of science. So obviously I did applied econometrics, which involves basically it's a combination of economics, statistics and mathematics. So I'll not talk about the quants part of it. The other part of economics is I'll talk about the liberal art part of it, is to look at things at a high level. So if you think of data science, I mean you have computation, you have statistics, you have mathematics, etc. But there is one high level thing which sits about all of them, and that is logic. If your logic is clear, I mean, be it anything, be it in your maths or be it in stats, whatever, you have to, in my opinion, if I have to sum up data science, I mean, there are a lot of, it's kind of open to interpretation, but in my opinion, data science or analytics is all about logic. In my opinion, if somebody has a very good understanding of the business problem or the underlying problem or his basic logic is clear, I think the tools part of it or the methodology part of it, it's about just the resource allocation problem. It's not really a problem in my opinion. And that's really what is happening today in the industry. So I see a lot of people going to companies, coming to us, like companies like Deloitte or any other analytics company. They just go and say, I want to do data science. And the person who is sitting on the other side of the chair is like, yes, I want to buy data science. And then the conversation ends. So they don't really know that what you are buying or what you are selling. So there is a complete information asymmetry. Now this information asymmetry can only be cleared if you have a clear logical idea about why you need data science. And everybody talked about data, everybody talked about data science, the evolution of data science, but nobody talked about why is the industry coming up. There are various reasons. If you look at it, all the theories that are there, like until 2000 or 2001, so I worked with an Indian Statistical Institute professor. So for banks, they used to use linear probability model to make model. You know why? Because there was not enough computational power, but the cost of storage of data was very high. Now the cost of storage of data has gone down phenomenally, and the computing power has gone up very highly. So now, because of these two reasons, there is value that is seen in the market. And because of this value, obviously whenever there is value, capital is channelized towards that value creation. that I need some insight out of the data. And that is where you need workforce. Obviously, capital cannot operate on its own, it cannot reap profit on its own. You need workforce. And this is a service sector, so obviously, you need some trained professionals. So that is why the economics of data science that's happening. Your data, if the cost is going down, the computational power is coming up, you have more resources in the market. And this PhD course, I mean, if I take this as an example, this is one big example. You basically molded few various disciplines of science, liberal art, into a package, right? Data science is nothing but a package, and this package demand is coming because there's a lot of value that is seen in the market, right? So yeah, I mean, until 2011, 2012, if you go and see companies who claim to be working in data science, you will see a guy from ISI, a guy from IIT doing from computer science, and you will find a business consultant somewhere in the middle, and they all claim to be data science. So that is good. I mean, there is nothing wrong in it. And that is something even if I look the synergy between me, Karthik and Abhishek, we see that. But as a package, this evolution that has happened, and it is going to happen. Like there's a term in the industry, I don't know how many people know this, there's a 2020 vision. So if there's a McKinsey report which says that in 2020, by 2020, there are various industries which will be automated. Various industries. And this is going to be a lot of, we all understand this shocks in the market, right? What do you call as the path-breaking technologies like Uber. Uber is a disruption. It's a disruption the way you waste. I had a very bad experience in Chennai. So every time I used to go and ask the auto rickshaw, I used to always haggle. You don't need that. You have Uber, you just go and book a cab. That's a disruption to the market, right? This disruption that is happening. Now this disruption is happening, if you look at Uber, it's nothing but a data aggregator. It is real-time data analysis that is happening with some predictive algorithm, right? It's a resource, it's a traveling salesman problem or something that you are solving in a real time, right? So this disruption, by 2020, there is going to be a lot of disruption in a lot of industries. And there will be a lot of automation as well. A lot of low-end work, I mean, when I say low-end, no disrespect to their work, but a lot of manual work, which is repetitive, which can be structured, and some kind of algorithm will be replacing them. Now, think about this. If that is happening, by 2020, so many markets are getting, so many industries are going to be disrupted by this, this labor force. A lot of people will be jobless. Somebody has to write the algorithms. Somebody has to write the algorithm. Somebody has to do the cerebral work to get this algorithm in place or to understand this, to sustain this disruption. So that is where you guys come in.
And I think just to take this thought forward, so the idea of all this thing is, when you are learning your courses and core algorithms, try to in your back of your mind, pick some kind of industry and try to follow it for some time. Just try to understand what you are learning right now, how you can reflect it upon some kind of industry which is evolving. Because that will help you become ready to go to the market. But if you just have tools and technology, still the industry people have to hire you and have additional cost of training you into their particular industry. But if you already start with somebody, some people might like this technology around Google, some people might want to explore around healthcare, some people might want to explore around travel and hospitality. Just try to start reading up articles and some reports. So the last thing for this before we open for the
One example also, when we talked about a lot about algorithm, okay, and when we were discussing a lot of things with Nadrajan sir yesterday, so we were emphasizing on the fact that people are only talking about algorithms, but algorithms are not always correct. If I will be really concerned, if I go to Yahoo News every day and if I read certain sections of the news, and based on my last 7 weeks of news reading pattern, Yahoo takes out certain news out of what they are offering. This is a flaw in the algorithm. You are getting less information.
Yeah.
So algorithms are also not always correct. So there is not just restrict yourself to algorithms. It's again, I'm saying it's logic. It's logic that needs to be quick. And algorithms, I mean, even in Google also, or I have a lot of friends for Google and online high velocity people are here. But how to tweak those algorithms? how to make them perfect. That is something we need to talk about.
And I think I will be, I mean, the last question for this session will be, I will be advocating students, So there is a, I mean, at least I am also a, product of a mathematics department. So I know, I have felt few things, I have seen my juniors doing the same thing. So when you are studying some mathematical courses, they are mostly abstract. And the one complaint the student will always come forward is, boss, I don't understand what is automata theory, why is two circles and this circle going, and how to regular expression and all those things. And even, I have great difficulty in understanding this theory of computing concepts. And I was like, sir, what is this? I don't understand. There is no practical application of all those things. Small things like, algorithms, big O, small O. What is happening with it? Why is so many sorting algorithms? Just put that into some click, this sort and it will sort. Why you need to do all those things? The students always complained about a lot of the things that they do in mathematics. Even I was complaining till I passed out, and when I started looking at a lot of things, which are happening there. So there is one specific thing I will just put it into context here. So, when the system is working perfectly fine, you don't need mathematicians. Because they are pushing data from somewhere, answer is coming. The moment answer is not coming, it can't be solved by a tool, it can't be solved by a person who is a veteran in writing codes, it can't be solved by a person who is, maybe have worked in the industry for the last 45 years. If an algorithm is not giving right answer, it's only a person who knows mathematics and logically break it and find out. Small problems like the algorithm is not conversing. Why it is not conversing? What are the boundary problems? Is it integrable or not integrable on the area you are doing? That moment, if you hit, you start appreciating mathematics and what you are doing right now in your courses. I realized it. I then started translating my complicated problems into simpler logical problems, and you will not believe courses like stochastic calculus, which is like how I should just pass the course, because this is so tough to understand. That now it is not getting differentiated over a real number line, but it's getting differentiated probability. What is this probability? Everything is in air. So I will maybe put up Devangana on spot right now. So Devangana, can you share maybe some course, something that you learned you didn't like, and maybe after working hot work for 1 year, 1.5 years, you think that it's very important, and thanks for keeping it brief.
So I think probably I'm the wrong person to whom you are asking this question.
But you are, I think, out of the lot, you are the recent pass out, maybe Venkat or Shruti is there, so I just want to put you on spot.
So
Maybe if Venkat or Shruti, if you have any specific course that you hated and then started appreciating after getting into Google. See, I totally
Yeah, I have an answer for that. It's kind of a joke.
Okay, maybe Venkat.
I would say that I think you just brought up things like automata, regular expression, what's the point of learning all of them. To be honest, I actually had some questions when I interviewed with Google, and without learning those things, I couldn't have been able to answer those questions. So there's one reason for you right there.
Yeah, see, regular expressions are not that bad. Yeah, sure. Yeah. I mean, yeah, so I think students started laughing and some energy, came back when they heard all these subjects.
So I think one of the key things is, I think two things that students can use a lot is, be inquisitive and use imagination. So if you can do those two things, I think you will figure out a way to connect your subject to something useful in the world.
Yeah.
Okay? And, a company became a verb, so, just Google. Just, so there's information available, right? And we just need to go figure out, somebody has already written a blog or an article about your question, okay? And you need to be persistent to find it, right? That's all. And you can build on it, right? So one subject, I struggle and actually advise, and, Professor Krishna, like that was operation research. So I think I liked it. It was just that I couldn't figure out how to clear it twice, right? But anyhow, so I think I was always trying to look for a place to use it, and when I found a company, we had to help the company move containers and optimize containers. So we kind of, I use some of the learnings to help them, actually do first physical models and help them, these are how to do it and then automate it later. Right? So you can pretty much in any subject you study, you can see a use for it out there. You just have to go look for it, then you will figure out that no subject is abstract.
And if you can't, your alumni is there, because the people who are just recent pass outs are the best people to talk around all those things. So Akatik can take the mic. So we will have open this for question answer. So I think I will take 5 questions, and I want you to come from different. Yeah, please, go ahead.
Yeah, I mean, I just wanted to say, since there are so many students here, I so wish I was sitting on the other side and not on this side. The reason is that when I was a student and I was looking into a huge data set, like when I was a student, even parsing through like 1 gigabyte of a text file was a really hard thing to do. But not anymore. Like the barrier for entry is so low. The key thing is because most of the major companies are open sourcing almost all of their recent technologies. Like for example, Google is obviously big on open source, and we have things like TensorFlow. I cannot imagine like the list of things I could have done if TensorFlow was out there when I was in college. So if you have an hypothesis today, and if you want to see if that works, all it takes is probably a lunch session in or something like that. The barrier to entry is so low, and you have all these tools available for you for free of cost. And I really think that that's one of the reasons why the college is even conceive a dedicated course for data science, is because the technology is available. And that is something that you guys should really take advantage of. And like I said, open source is a really big thing. So no matter what you do, how simple it is, try to put it out there. You will never know who's going to search for something similar. Let's say you solved a very simple problem. Let's say you figured out how to bring more people to a conference like this based on some past data. Somebody is looking for that might end up in your GitHub page by Googling, and they might end up making it better, or they might find it useful. And the possibilities are endless. And that is how most of the projects today came into existence in the first place. So the thing I really want to insist is that make use of all the available open source tools, and whatever you build, try to put it out there open. It is going to help you for recruitment, and it's going to help others find your work.
Yeah, Vignesh, and one more thing, you just touched upon a few things. So we have been troubling Radha sir for at least 1.5 months to bring the best infrastructure here, so that if they really want to do on some graph thing, they should work on 20 GB graph, not just 5 students or 10 students. Because if you don't see the scale, you are actually not ready to face the real things. So, and you will be happy when sometime you visit, that we are coming up with I think 2 to 3 labs here, and I have seen the server rack. Hopefully that will have a lot of GBs future. So, so we are just running out of time. Shruti, you just want to add something really quickly?
I just have a very generic closure. It might be repetitive, I'm sorry. But as many of you in the conference might have stressed, I think there's no place I can think of today where data science is not used. And then, as the other panel members might have spoken about applications in video, pharmaceuticals, and health, and chips and whatnot, the challenges and the challenge is way beyond what Devangna mentioned about how to handle data with limited storage and connectivity. So for me, when I just see a whole world of opportunity with just the 4 words called data. And as Vignesh mentioned, there's just so many resources online, you can just go grab the knowledge you want. I would love to see each of you there come up and work on some part with the data in the field that you're really interested in. And you never know, you'll be budding entrepreneurs in the future. That's about it.
Yeah. So now we'll open the floor. Yeah.
So another thing, just
Sorry about that. There is one aspect. Go ahead. Go ahead.
No, I just want to tell all the students that don't feel shy. If you want to get in touch with us, I don't know, you probably already have us all on Facebook or email or whatever it is, so feel free to get in touch with any person. We'd be more than happy to help with whatever you want.
Thank you. Yeah, throughout the years, there's one thing I've learned, that is people actually are pretty good, and I didn't working with algorithm, working with the data. But pretty much with all the projects where I failed, the number one reason why, if you did the analysis, was we were solving for the wrong problem. Because data science as a world is very complex, you end up solving for the wrong problem. And if you did look into that why, most of the time, it actually boils back to some communication failure. So one of the critical components of a data science professional is an ability to tell a story. Like, it doesn't matter, like you come up with the greatest analysis and go and present it to your business owner saying that the R square of this model is 0.96, so it's spectacular. It means nothing to them. You have to translate whatever you're learning from the model into the measures and the metrics they understand. For a financial manager, it might be the dollar amount that they're going to get more because of this. Or if you're telling to a healthcare professional the life that you're going to save. They don't care about the metrics of the model. They don't care about the data. So inculcating that ability to tell a story is extremely critical, both vocally as well as written. And I don't know if the course has covered that aspect of that, the communication aspect of that. But that, to me, is extremely, extremely important.
So, first apologies to Robbie and Vapan. I will be taking your time now, but I think the energy level is high right now, so we'll just open up, and maybe after the Vapan and Robbie session, we will limit question answers to maybe one or two. So if you have something, don't wait for it. It's the right time. So I will appreciate if from different corners, different questions can come, and I will encourage faculty also to ask, because for them also this is a different kind of perspective that these people are trying to push into here. So maybe we can start anybody volunteering from backside there, some question, and feel free if you just want to ask, where barcode chain can be used. That's also fine. But just try to, Hello. Yeah, there's someone here. And guys, please be ready for next question. I can go for this side as well. Right side.
So, an introduction and be very articulative about your question.
This is Practice, studying third year MSc Software Engineering. It's about, for the past session, data was the word which was used most number of times. We are very much concerned about data now. Are we going to end up storing the data, concerned about storing the data and then maintaining it, and then looking upon the data always, or how is it going to be done? Like Internet of Things was one of the things which was said. If it's going to be IoT, each and every point of particular point of data will be stored, and then will we be ending up storing the data more and maintaining it more than using the data?
Maybe Robbie, you just want to take this up.
It's actually a great question, because this 5 years ago we never worried. Whenever people came to us, we just told them, save everything, right? Save everything forever. In fact, most of the disks are write-only disks. You just get the data, write it, and it stays there forever. But with IoT, that flood is actually becoming overwhelming. But the good thing is, companies with a lot of money, like Google's, right? For them, it's even more pressing problem, and they are coming up with very creative ways. So, Venkat, do you have any thoughts on that? Vignesh.
Yeah, I mean, it's kind of a funny thing that we should mention storage, because obviously I work with YouTube and we store humongous amounts of data. There's usually a funny statistic in YouTube where they say that 99% of the videos get viewed like exactly one time. So it's basically just 1% of YouTube videos that more than one person is watching. So that's a pretty humongous, that's a pretty significant amount of data that's just sitting there, taking up all the space if you think about it. So, and obviously storage is getting cheaper day by day. It's a lot easier, especially for students if you're looking at entering into some kind of data scientist. So when I was in college, like I said, 1 gigabyte of data set was a pretty big deal. But these days with cloud and AWS free tier and things like that, you have the ability to process gigabytes or maybe even petabytes of data like right from your laptop without doing much of an effort. So, I mean, I don't really have an answer to how IoT is going to affect storage in general, but one thing is that storage is definitely getting a lot cheaper than it used to be. And like I said again, the barrier for entry is kind of low. If you want to get into a startup, you can still do that without investing a lot in data centers and things like that.
Yeah, I can give a couple of examples. It used to be, say, if it's at a record level, right? Like if you're talking about information about all the students, the entire country, the entire world, it's very easy to store that information. But let's say you're talking about jet engine, right? When an aircraft goes from point A to point B, it generates multiple gigabytes and terabytes of data. So at least in the IoT space, I work on a couple of projects where we are going back to best practices in using traditional statistics. Either you sample the data or you just store the anomalous data. Like if a jet engine is working fine for most of the part, you keep sniffing the data. And if you notice an error, just retain last 15 minutes of data. Again, these are optimization techniques that we are using. We are starting to use in our scene that one and automobiles where you're using sensor data. But that's where we're headed, you know.
Yeah, now this side of the this side from this side. Okay.
Hello, this is Pavitra, second year theoretical computer science. I have a question that is, whenever you people speak about data and when you work with data, you work with the data that pertains to your domain. That is, whenever you work in banking, you work with data that is related to banking and recently I heard a news, I read it, that is the database of Mumbai Railways was hacked and huge data was stolen and it was sold to European industries. So what could they do with some data that is not even related to them, that is Mumbai Railways. So whenever you do data analytics, you need data that is related to that domain, or you need some near data, and what do you do with that data?
I'm sorry, question. I don't know if HOD Natarajan sir is there. I would like to borrow his sentence to answer this question, kind of. So when I was in college, we always used to say life is about two things. Problem solving and pattern matching. So your question falls kind of in the second category where it is about pattern matching. I don't exactly know the answer for that particular case of the Mumbai Railways thing, but there have been instances in the past where people have solved a problem in one domain and exactly replicated the solution to like a totally unrelated domain. One example off the top of my head is that I think it was Microsoft. So you know how the disease called AIDS. So the way AIDS affects your body is that it goes and targets the immune system first. So immune system is in charge of protecting viruses. It goes and hits that directly, and that kind of that line of thought was applied for antivirus software where. There was an antivirus software which went there was a virus which went and attacked the antivirus software first before getting control of the system. So it's not uncommon at all for data from one domain to be translated to some other domain and be incredibly useful.
So one thing to add on to this, there is a lot of talks around data ethics, right? So data ethics, privacy, and so on. So the case you are talking about is a physical interruption on systems and then hacking something out of it, right? But what you will do for systems like, let's say Google now, they read my emails, right? So they read my emails, they know when is my bill pending, so when is it due, and they know when I am traveling to one place to another place. So all these privacy, data ethics, and hacking kind of things which we are talking about, certain things are very bad in one term and certain others are really, really good. So if you allow it, it will give you something much more than what you would expect. So my life is made easy by Google now, right? So something of very similar thought line is there in other domains as well, where personalization is coming a lot. Amazon's product recommendation. Again, they are using your purchase data. They know what you are buying. They know where you click, right? So all of this data is looked after, and on top of it, something is being done. Google's ad work, nothing different. So there are always these two sides, one bad, one good. Good is always for your benefit, and bad obviously is bad.
Maybe go quickly. Yeah.
Use case. Your question was, to be very honest, with how data from one industry is being used by another industry. I understand correctly. And it's completely unrelated. I'll give a very interesting case. So, in the airlines industry, there is a downtime and there is an uptime. It's kind of a cycle. So, Deutsche, so there is a German TV, that is DWDV, Deutsche, I'm forgetting the blue part of it. So, they were in business with Lufthansa. So, you would be wondering how. So, Lufthansa is having flights all over the world. Now, when an aircraft is traveling, through its sensors and etc., it is collecting data on weather patterns. That data was sold to Deutsche and then DWDV, and that includes their weather prediction, forecast prediction, confidence interval of it by 20 to 30%. And that was data sold, that kind of weather information is sold to the local farmers, the metal industries, etc. So you see, data is very fluid concept. We put it in any industry, it takes the shape of it. Right? So this is one part of it. Second part is privacy in the application. This is very good. Thing that you pointed out. Privacy is a very big problem. Data privacy is extremely big problem. If you come with me and see where I work for banks. I work in a classroom. You cannot really take a mobile phone inside it. You cannot even go inside that particular other than yourself. That is very special access. So privacy is a concern. A lot of European Union countries are coming up with regulations where your personal can opt out from personal data information collection. So Google might not be able to do some analytics by using it as a case study. There are certain regulations and concerns which are coming up. So because it is a concern, in my opinion, when there is a good part to it is that I get a customized product. But again, like I said, like you are reading a newspaper and on a daily basis certain news are taken out. While you are reading patterns, then you are using a product information.
Yeah. So I think last question I encourage any of the faculty member if they have some thoughts.
Just one last
thought. Sorry, Lokesh. This is just the last privilege question for any faculty members here. If they have. So we can break out after that. You can ask any students if have some good questions. So maybe someone from faculty can just have some thoughts from their perspective, because the student's perspective is very different from yours. Maybe anyone.
Yeah.
Hello, Karthik. Only from
top.
From faculty.
From faculty.
We will have, sorry, but we will have offline.
I talked about data privacy. Now, especially in the healthcare sector, personalization of medical records is very important. But it was from country to country, correct? So, for an Indian, actually, some of the medical related data may not be very personal, but in America, it is treated as a very personal data. Am I correct? So, in India, people, when they talk to the others also, I am suffering from this type of disease and all, but in America, they won't actually disclose it. So, how do you actually frame some particular rules or some strategy so that you can actually make this data privacy as a common one for different areas also?
So this is actually a very complex problem. In fact, I did not appreciate the complexity. I mean, if you think about a website, you go, you give your email ID, you register, you become a user, right? Whereas when you talk about healthcare, it's a lot more complicated because you're talking about very critical data. Something as simple as, I have my data, but do I want my wife to know all of it? right? It's a problem, right? Now, I might want to just share some of them. Or if I have okay, I'm talking about an average people over there, ex-wife, right? What do you want to share? Now, how about children? Like, you take your kids to doctor, do you want the parents to know about the kids' information? Now, what happens if the kid turns 18 and becomes an adult? So this is an enormous problem. Like, how do you deal with it? So, the way that this is being handled right now is by consent. Like voluntary consent, if it's a child up to 14 years or so, you pretty much have unconstrained access to child's data, but beyond that, and then let's say if you want to know about your parents who are in older age, then they have to consent. Honestly, there is no elegant solution that we come across. In fact, it becomes messy when you travel from country to country. They all try to bring in their own regulations. So really, like, I've not come across or seen any elegant solution.
What I feel is, you see, in some domains only you can replicate the algorithms to different types of data. But when you come across this type of actually problems, I think that it is not possible to replicate the same algorithm to some other domain also.
Yeah.
Your strategy should be different actually, everything will be different.
Exactly. And to top it off, new laws might come in, so we might have to accommodate those laws also. So it is more or less handled on a case-by-case basis.
One more small doubt. See, you are dealing with a lot of data. What about the lifetime of your data? Whether we have to store the data always, or there is some lifetime for the data such that the data may not be useful after some time. Okay? So whether we can actually delete the data, that type of data, how do you identify that one?
Okay. So traditionally, like you can, usually again, I would classify the data into two. One is transactional data, another one is analytic data. Say if it's bank records or real estate records or anything like that, you keep them forever. Because those are transactional information, right? Now, the footprint of those things are not much, so you can afford to store these things forever. Now, when it comes to analytical records, a lot of times things are legally mandated. For example, when I was working in the ad targeting industry or somewhere, they wanted 12 months plus, so 13 months of record. So you roll over every 13 months, which is probably more than sufficient for ad targeting industry because that's a lot more dynamic. And you can also apply, I forgot what it is, but it's basically some entropy thing. Meaningfully, like what is that you want for analysis? If you think your business cycle is 5 years, probably you won't need it for more than 10 years. So 2x kind of data. So you can use that as a benchmark. But it's usually, then you can also start with the sampling methodology. If you're just talking about analysis, random sample 5% or 1%, and just store that forever. And this is something we have to acknowledge though, because if you're sampling, you're losing information. So if you don't know what you're asking, you're going to lose it, but that's the reality.
Yeah, so as part of my experience with the database team, I was at the management side as well, management of the data as well as the analytics on it. So in Reckitt we had a policy of 7 years. So 7 years is the period when you store the data in live databases. After that, all these data are moved to disk, and these disks are in data centers. So you really cut off yourself with that data after it moves to disk, and anything which needs to be done on top of it has to follow a big process in the company itself to get it back, even a chunk of it, or entirely as you would wish. But it is completely a subjective call from the expert, from the business owners, to when do you want to do this kind of archiving.
So I can just close the session. So special thanks to Vignesh and Shruti for
Just to mention here, Shruti just traveled back from India, and she, I think, just reached US today only. And even I don't know if she is feeling jet lag or she is very tired, but she's still accepted to join. Thanks a lot, Shruti.
a broad perspective of how different industries are looking at the same data. The next sessions, the 2 sessions are very specifically curated, and we have thought through them before presenting, taking these people in the head. So they will be very specific to some industry and the way the industry is looking at it. So what the expectation is, you just try to understand how they are dealing with few things, and just try to inculcate, and when you go out, just at least try to think about these 2 industries. So I will welcome Gopan, maybe the Robbie first. And I'm really sorry, I mean, I have cut across our time maybe to 20 minutes now. So just try to go.